to day 4 of our faculty development program. We are excited to continue our exploration of cutting edge technologies and innovations in machine learning and security.
Good morning. नहीं पापा, इसको मीटिंग स्टार्ट हो गई।
Good morning, sir.
Good
Good
morning,
morning.
Vani ma'am. Good morning.
Sir, we will start the session within 2 or 3 minutes. Participants are
Uh,
joining.
yeah, yes, 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 yes.
Thank you, sir. So, shall we start?
Yes, ma'am. We can start now.
Good morning, everyone. I welcome you all to the day 4 of our faculty development program. We are excited to continue our exploration of cutting edge technologies and innovations and machine learning and security. Let's welcome our speaker of the session, Dr. Yogendra Mohan from Northeastern Regional Institute of Science and Technology, Arunachal Pradesh. He is a Deputy Head of Education Technology Cell, NERIST. He has 18 years of teaching experience and 2 years of software development experience. He is PhD from DTU New Delhi. He is the author of the book Essence of Physics, Chemistry and Mathematics. He has supervised various B.Tech projects and M.Tech theses. He has published various papers in reputed SCI, SCIE, and Scopus journals. He is a member of IEEE and IEI. He has also served as a session chair and member of various reputed international conferences. I kindly request Dr. Yogender Mohan sir to start the session and share his expertise with us.
Thank you, ma'am, for
Sir,
very nice introduction. And
thank you,
share
sir,
my
for
PPT,
your
please.
time.
Thank you, ma'am.
Yes, please.
Ma'am, I'm trying to share my screen, but not getting the option how to share my desktop because I am having two PPTs. So I will share one by one both. So that's why I'm trying to just share through my.
Right now, only that Zoom window is showing.
So there is a share option, new share option, ma'am, right? And it's not getting ma'am option to share my desktop actually. So there is only this Zoom screen. It is visible here, and one more my PPT that is already open. So just a minute, let me
So you,
open the
you can,
PPTs first. So possibly it will work now. Just a minute, ma'am.
okay, sir.
Ma'am, my screen is visible. Just please confirm.
Yes, sir. It's visible.
Okay, okay, ma'am. So just okay. Good morning, one and all. This is Yogendra Mohan, Assistant Professor, Department of Computer Science and Engineering, Northeastern Regional Institute of Science and Technology, Itanagar, Arunachal Pradesh. And we will start with the just content. By the way, our topic is optimization technique and application. So briefly, we discuss about the history of this meta heuristic optimization, and then followed by what is optimization algorithm, what are the differences between deterministic and stochastic approach, then some brief classification about the stochastic optimization algorithm, and then some basic algorithm, that is hill climbing optimization algorithm, simulated annealing, evolutionary algorithm. And after just discussion of these all topic, I'll take one case study for the node localization in wireless sensor network using the Siegel optimization algorithm. Ma'am, some of the just participant requesting, so I have to admit these all, or you will be doing from your side. Ma'am, can you hear me? Am I audible?
Yes, sir.
Yes,
I'm.
sir. Okay, just asking this, the some participant is giving the request to join this session. So you will be doing these all things I have to do in between now the session.
Sir, we are admitting.
Okay, thank you, ma'am. So I just
Okay.
now going to start the session now. Thank you. So very first, uh, let's discuss about what are the heuristic approach and meta heuristic approach. So if I would like to say that very first, when these approaches are heuristic and meta heuristic approaches are not popular, then most of the time we were using that some deterministic algorithm to solve the problem. And the deterministic algorithm, they are still relevant, but there are some limitation with the deterministic kind of algorithm, although they give the very accurate results. But sometimes the time and the cost, it is again a very important factor. So that's why now the meta heuristic algorithm now is very popular, and we are able to use in the various complex problem solving technique. So deterministic approach, as we know that it gives the exact solution, and there is the some set of deterministic approach. So there are some finite number of steps, and it will be solved using that steps, and we will be getting the some exact solution. So this is the goodness of deterministic algorithm. Heuristic or meta heuristic algorithm, they are up to some extent it is good if you are considering the time and the cost. But if you are just coming to the point that the results, then sometimes it is varying from the exact results. So there are some good and bad traits of the meta heuristic approaches, but still it is popular. And how it is popular, so we will be discussing in our discussion. So if I say that history of the meta heuristic optimization algorithm, then conventional approach, it was the design with experimental model. Design with experimental model, it is a very conventional and old approach in which we apply the hit and trial method. Sometimes it's we are just, suppose we are going to develop some model, and in that case we are just making the so many models, and sometimes we are just now getting the wrong product. So if this is a design and experimental approach, sometimes we are trying more than one time, and then after so many iterations, yeah, so many experiment, we are getting the right product. So in this process, sometimes it is very time consuming, it is very cost effective, not cost effective. So then along with the time, along with the technological advancement, there is another approach that is become popular, the design with simulated model. Simulation, it is the approach which give the some idea, and through that idea we can have the better model or better product. But still this model sometimes is not giving the better solution with respect to time and cost. So outcome of these all, it is a designing of the model with the optimization algorithm. Now we will discuss the merit and demerit a little bit more detail in these all, then we'll come to the optimization algorithm. So if I'm telling about the designing with the experimental model, there are some disadvantages of using this model. First thing, it is very difficult at the very beginning. After 3-4 iterations or so many number of experiment, we are getting the some logical solution, and it is obvious, it is expensive reason behind. After so many trials, we are reaching to the solution point. Time consuming, because it is so many iteration, and now involvement of human, it is more and more as compared to the current scenario, a current optimization technique and model. And sometimes it is not accurate. We are developing the things with a lot of ideas and some guideline, but still we are not getting the right product. So sometimes it is not accurate. These are the some demerits of using the experimental model for the development of any model or any things. Second approach, it was the design with the simulated model. In the simulated model, comparatively, the experimental model, it is fast and it is cheap. Reason behind, we are in the simulation scenario, we are not using the hardware or the tools and for the development of the model. Through the simulation, we can reach to the reality, and once we are very close to the reality, then we can go for the design and development of the things. But still, the sometimes simulated model, its design process, it is now the slow, and of course the human involvement, it is a little bit less as compared to the conventional experimental model. But still the human involvement, human resources required more requirement as compared to if we will be discussing about the optimization technique, and sometimes it is error prone. Now come to the design with the optimization algorithm. This have a lot of advantages. The very first, it is a fast modeling approach, and we can have the because of a lot of algorithm it is available, we can go and we can analyze and we can just find out the so many feasible solution, and now this way we can make the things faster, and design process fasted, it is automated, and we can have the minimum human involvement, resource person involvement is minimum, and that is very less error as compared to the previous two model. But still the design with optimization algorithm, we can say meta heuristic optimization algorithm, they are very complex. So if it is complex, then definitely the computational overhead, it is going to increase. Along with this, the second and that is the biggest disadvantage of using the optimization algorithm, they are not able to solve the real world problem or real life problem, because they give the some solution that is not exact solution. They are very near to accurate solution. That's why we say it is a some feasible optimal solution. Now come to the just the deterministic approach and modern stochastic approach. Deterministic approach that I discussed, told briefly about that. Now deterministic algorithm, that is very conventional approach, and we are applying the set of rules in the step by step, and we are getting the exact solution. But this approach required a lot of time. And suppose I'm taking here one example. What is the difference between deterministic algorithm and modern or stochastic approach? Suppose we are in the field, and the field, it is a very large, and we are just playing with the ball, and our ball, it is missed out in the ground. Now one approach that to find that particular ball is, we will start from any corner of the field, and we are just in the clockwise or anti-clockwise, we are just stepping and trying to search that ball. And then definitely at the end of time, because we are searching each and every place of the particular field, so we will get the ball. But what is the problem with this? Now we are just searching the complete field, and we are following either clockwise or anti-clockwise direction, and we are just putting our feet at the each and every places of the ground. So this way, sometimes if you are the 2% or 1%, then 3%, 4% searching the same ball, it may take the whole days. This is called the deterministic approach, because we followed the clockwise or anti-clockwise, and we are searching all together, and they're covering the complete field, each and every area of the field, and now finally we got the ball. So this is approach that we can say we followed the clockwise movement, and we are covering the each and every area of this field, and finally we will get the ball at the any point of time. Sometimes the chances are more we will find the ball at the very beginning, but it is not the guarantee we will get the ball at the very beginning. It may happen that we are getting the ball at the last point of the field where we search out. So this is the deterministic approach. In the stochastic or non-deterministic approach that we say it is a modern approach, there is another approach. We can randomly move in all directions quickly, and then there is not the guarantee we will able to find out that particular ball, but chances are more if you are getting the ball, we are saving the whole days. We can search the ball in the some fraction of day, means 1 hour or half hour, sometimes less than that now. So this is the differences between the deterministic approach and you can say and the stochastic approach, a modern approach to find the solution. And then there are some advantage of deterministic that already discussed. Now what is the advantage of using the deterministic approach? They are reliable. They always give the very accurate results, and required just less number of function evaluation sometime, and they give the very accurate results. Drawback, it's sometimes stuck into the local optima stagnation. I will take the example. At that time we will able to understand what is the problem with this, what is the local optima stagnation, how we stuck somewhere in the searching of the things, and then low chance of finding the global optima. High, and the another thing is now the high dependency on the initial solution. It's very important in case of deterministic approach, and mostly need gradient approach. So these are the some limitation advantage of using the deterministic approach. Now modern approach have the some more advantages over the deterministic approach. They avoid the local solution. So and they this is the way we are saving the time and higher chance of finding the global solution. low dependency on the initial solution, and mostly do not need gradient value in the computation of the complex problems. Drawback still it is now the sometime it is a slow coverage region behind the algorithm of the meta heuristic. They are complex algorithm, so computational overhead may be more in case of meta heuristic optimization or stochastic approach. Finding different answer in each run, that it is very sometimes there are so many solution, and some of the solution are the local optimum solution, so that is not the global solution, but they are the some feasible solution. So in each run we are finding the a lot of some solution, so we have to take care now to which one is the optimal solution out of these feasible solution. So these are the demerits of using the stochastic approach or optimization algorithm. If you now come to the optimization algorithm, if I broadly classify the optimization algorithm, then this can be classified into two categories. One is the individual based optimization algorithm, another is the population based algorithm. An individual based algorithm means there is a single search agent that is trying to find out the optimal solution or global solution. And in case of population based algorithm, there are more than one search agent that is searching the optimal results or optimal solution. So that is called population based algorithm. Some of them it's very common. There's what is particle sum optimization. It is a very common algorithm where just a group of folk of bird, now they are just going in the search of food, and so this is an example of the population based optimization algorithm. So we will discuss one by one. In this meta heuristic optimization algorithm, there are two very important phase and that need to discuss, and that's very important phase in the optimization of meta heuristic algorithm. So very first is the exploration phase and second is the exploitation phase. So exploration phase, in which we are trying to find out the in the search space, we are finding the particular position. It may be the local based or global based, and once we are able to find the local or global based, then we are going to exploit and we are going to examine the particular solution that is either local based or global based. That is called exploration phase. So these are the two phases that we will be using in our meta heuristic algorithm. We will discuss later when I will start the some meta heuristic algorithm discussion. Now, there is an algorithm that is very popular now, no free lunch theorem. Although there is a very good advancement in the development of meta heuristic optimization algorithm, but there is no such algorithm exist that can solve all problem, all stochastic problem. Any algorithm that is not developed so far, that where stochastic approach can be applied to solve the all problems. So for some set of problem, we have the different set of algorithm, and for the other problem, we have the different set of algorithm that we will be using for the. That's why we have just I want to show the some very few list of meta heuristic optimization algorithm. So that is listed here now. We will not discuss in everything, but broadly I will just explain about what is the category of these all now, and very few we will discuss in the case study. So optimization technique, if we broadly classify, then we can say it is a conventional technique, and there is a non-conventional. Conventional means this is the old method that's now have been used for the long time, and non-conventional method in this is a stochastic approach that we say meta heuristic optimization technique. So conventional technique, this is classified into the network method, calculus method, and mathematical programming. So they are the deterministic algorithm, algorithm, and they are giving the exact point of solution. And the merit demerit that we already discussed about these are now. So if we broadly discuss about the non-classification, non-conventional algorithm. So this is a meta-heuristic optimization algorithm, and this is further classified into the 4 categories, that is evolutionary algorithm, swarm-based algorithm, and physics-based algorithm, and bioinspired algorithm. So some examples of these are given now here. The algorithm are now. So just evolutionary algorithm, that there is a differential equation, genetic programming, genetic algorithm, genetic expression algorithm, yes, harmony search algorithm, and evolutionary strategy algorithm. They are the evolutionary algorithm. Swarm-based algorithms are the gray wolf optimization, particle swarm, Emerson and Merriam. This list are given here now. Physics-based algorithm are the gravitational search algorithm. It is the one of the best known algorithm, and many more it is listed out here now. And similarly, there are the bioinspired algorithm, the Spiro search algorithm, BAT algorithm, yes, Foucault search optimization algorithm, flower pollination algorithm, and many more. And the butterfly optimization algorithm. So these are the algorithm. These are used for the solving the some set of problem. So I was told now that there is no one algorithm that can solve all problem. That's why we are having the some varieties of meta-heuristic algorithm that can be used for the solving the different problem with the different set of algorithm. Now, here is a brief history about this algorithm. It is started from 1940. At that time, heuristic approach it was followed. Heuristic approach it was followed with the sum, and but in the after 1960-63 there is a again this evolutionary algorithm it is now designed, and that become popular in 1966 66, and now we started using this algorithm with the some meta-heuristic approach. So I'll come to the point about the difference between heuristic and meta-heuristic approach a little bit more key. What is the heuristic, then further what is the meta-heuristic. So after this, let's see the what are the history of the evolutionary algorithm and the genetic algorithm, these all. Then I'll come to the point again, what is the meta-heuristic and heuristic. So then after in 1960 and 70, this genetic algorithm it was developed, and it's become popular in and published in 1975. And in 80 and between 80 and 90s, there is a simulated annealing algorithm in 1983. It is published and become popular. And then after, there is a artificial immune system algorithm in 1996. This is another meta-heuristic algorithm that came into the existence and become very popular. So they are the some history. Along with that, that we have seen, there are a lot of algorithm that is now very popular. One algorithm that I could remember now, there is a whale optimization algorithm. It is developed in 1916 by Syed Mirza Milli, one Australian professor, and that's very, very popular algorithm as of today now. So there are very brief history about the meta-heuristic algorithm. It's not possible to list out everything now, but we can just find out on the Google. There is a huge list of the meta-heuristic algorithm that is there, and you can search and find out according to your interest and your requirement of the problem. Now, I'll discuss some algorithm, how it's now it is become popular, and how the next algorithm it is came into the existence, and the second one now the further become popular. The very first algorithm in this is now the hill climbing optimization algorithm. In the hill climbing optimization algorithm, you can see it is a greedy approach and traveling salesman problem that I hope you all are familiar that this is a greedy. This is an example of greedy approach algorithm. So hill climbing optimization algorithm, again it is that kind of algorithm where along with that, this is a graph. Suppose this is an objective function, and this is the state of this line. So the state of space. So in this is the solution space in which we are trying to find out the some global solution. So what how hill climbing optimization algorithm work? It's depend upon where is the starting point of the search agent. If our search agent it is suppose this is the suppose soldier, it is available at this point, then search agent, it is moving and comparing the point. If this highest sorry highest point, then soldier, it is moving toward the right direction, and it is found that there is a position that is higher, this is the higher the height is more than this one. Now soldier is moving towards the uphill, and further it is comparing to the next point, and this way it is reaching to the this global point now. So this may be the solution, this is the global solution, and it is able to find out the optimal solution. But if this soldier is not that we mention in our diagram, if it is here, suppose it is the current situation, a current position, it is here now, the current state is here, and in that case the soldier is now going to compare the 2 points adjacent nearby the situated the soldier. So if it is going to compare to adjacent point, so this side is now, it is the uphill and this is the downhill. So if there is a 2 point, one is uphill and one is a downhill point, so then soldier will move towards the uphill, and it is going, and it is now, once it is reached at the local maxima, and then it is going to compare, and it is, there is another point it is found that is downhill point, and then here this soldier is stuck at this point, and it assumed that this local maxima, it is a global maxima, and now this will declare as a final solution. So you can say now sometimes optimization problem, they are also stuck at the some local optima if it is not properly taken care, or some sufficient set of criteria is not taken into this one. So later it is optimized now, and then hill climbing algorithm, it is an adaptive hill climb algorithm that was searching in the both direction, so it was possible to find out the global solution. So this is the limitation of this hill climbing algorithm. And the other thing, it is depend upon the where the search agent is going to start. If search agent is going to start from this point, then search agent will be able to find out the solution. But if search agent, it is going to start from this point where current state is written over there, then it definitely it is going to stuck at the local maxima solution. So this is the limitation of this one. There is no backtracking approach in this. Now this is another algorithm. It is known as, we can say, this is a simulated annealing. It is hidden over there now. This is known as simulated annealing optimization algorithm. In this one, we can say it is the variant of hill climbing method, where search agent can move up towards the uphill or can downhill in the both direction. That is feasible with this simulated annealing optimization algorithm. Now in this case, starting point is not important, and with the a lot of trial iteration, it is possible to find out the global solution out of a set of feasible solution, that is called simulated annealing algorithm. Now there is another advance in the algorithm, and it is called evolutionary algorithm, that is published in 1975, and now it's very popular algorithm and very useful algorithm in the today's scenario. This is called example is that now the genetic algorithm, in which the very first we are having the very some set of random sample. Now we generate the new population from set of random sample. Now we design the evaluation criteria, and that evaluation criteria largely depend upon what kind of fitness function we are using and how we are evaluating the fitness value of this fitness function. Once the fitness value it is evaluated for all sample or search agent, now then there are the two possibility. If fitness function it is meeting our criteria, then we will terminate the algorithm here. But if fitness function is less than the threshold value, then we are going and performing the some set of operation that is called illicit policy. Means we are find the best out of out of available sample. So mutation and crossover, it is done with the chromosomes, and we are getting the better new population, and using that new population again we designing the evaluation criteria, applying the fitness function and calculating the fitness value, and if fitness value it is meeting our criteria, and then we are uh, uh, going to terminate. Otherwise this process we will continue again and again, and finally we'll get the global solution or optimal solution. So this is a genetic algorithm. The time and is not, I think it will allow me to just discuss about the genetic algorithm in detail. So briefly I am discussing about this. If we'll get the more time, then we'll come back to and we can further discuss about in detail about the genetic algorithm. So this is the basic idea about the evolutionary algorithm. An example is genetic algorithm. So now I just able to finish the basic idea about the this what is a meta heuristic algorithm and optimization technique and various classification and these all. Then we will come to the point and we will discuss about the what is some case study for these all. So I was discussing about the meta heuristic and heuristic. So there is a one difference that we can see here now. Meta heuristic, it is along with the randomization of the some set of variable along with the some heuristic approach, we can say it is a meta heuristic. Yeah, you can say meta heuristic, it is the high level of the heuristic approach. Now today we are using with the all meta optimization algorithm, that is called meta heuristic approach. Meta means sometimes the literal meaning of meta is beyond the limit. Beyond the limit. Heuristic means it is a kind of deterministic approach and applying with the beyond the limit. Now the whole phenoid now called the meta heuristic approach or stochastic approach. So I could just finish the first part of the basic of the meta heuristic optimization algorithm. If anybody have any query, we can discuss now. Then I'll move to the next case study related to this optimization algorithm. So anybody, if any query you have, you can ask now. Then I will move quickly to the next topic, that is the case study of meta heuristic optimization. Yes, ma'am. Can you hear me?
Yes, sir.
Ma'am,
You're
I
audible.
was audible enough. Yeah, I couldn't ask by the way.
Yes, sir. No, you are
Okay, fine.
audible enough.
Okay, ma'am. So if any query is there now, this audience want to ask anything regarding, because quickly I finish about the meta heuristic algorithm. It is not very detailed things, because I'm having just 1 hour, I have 50 minutes, 70 minutes. So that's why the material, it is very little. But still, if anybody have any query regarding this one, then we can discuss. Then after I'll move for the next topic.
Okay. Any questions from the participant side? I think right now, sir, no questions.
Okay, ma'am. So it was quite audible, ma'am, now. So yeah,
Yes,
PPT
yes,
or
sir.
all thing, it was moving properly, now.
Yes, sir. All things
Okay,
all are
sure.
very smooth.
So okay, thank you. So I'm going to stop this PPT and I will share again the second one, and just I'll get back to you quickly. Ma'am, my screen is visible.
Yes, sir.
Okay, ma'am. So By the way, quickly we finished, discuss about the meta heuristic optimization algorithm. So here I'm going to discuss one in wireless sensor network node localization technique, and in that I have been applied the meta heuristic algorithm. The name is Siegel optimization algorithm, along with the chaotic function to for the simulation and the optimization of the result. And results, what is there, uh, we are there is a some environment, and in environment field we deployed the some set of sensor node. And just quickly I will just start from here so that it will be easy for everyone to understand. So what I'm trying to do in this one now, here is the some sensor field, and there are some set of two types of nodes are there. One is the GPS enabled sensor. The GPS enabled sensor, they know their location, but other sensor are not GPS enabled. So our task is to find out the sensor position where it is deployed. So this is the task. But sometimes whenever we are going to apply the some method to find out the location of the sensor node, it is not giving the accurate result, and sometimes results are more. So for that, for further improvement, I'll be using the SOA algorithm, and then there is another modification in the SOA algorithm, that is chaotic SOA algorithm, and then we will do the performance analysis and comparison between SOA and CSOA algorithm, which one is better. So this is the task that we will be doing in this application. So that's from this figure, it is just very high level diagram. And in this diagram, you can say there is some target node, that is a unknown node, we can say non-GPS node. And there is an anchor node, they are enabled with the GPS, so they are able to find out the location. So we will use here RSSI method to find out the position of unknown sensor node or target node. And but that position, it is determined by the RSSI method, is not very accurate. So to calculate the better at least position, not it will be the exact solution, but we will be able to find out the nearby solution using the RSSI and SOA. So why SOA I'll be using here now? There is a calculation of distance when we are going to apply the RSSI method. So we calculate the distance between anchor node and the normal node, that is called target node. So in this calculation using the RSSI method, sometimes what happen, it calculating, but because of some environment effect and just obstacle or underwater, underground, or any kind of obstacle in between the anchor node and target nodes are there, then there is an attenuation problem. And so signal propagation, we know that it's going and it is going to now down, that is called attenuation problem. So calculation, calculated distance between anchor node and target node, it is not correct. So in that case, the distance that is be calculated now, and this distance we will apply the fitness function. And what is the fitness function? We will calculate the difference between actual distance and distance calculated by the RSSI method. That difference, we can say it is error. So here we will apply the fitness function to minimize the distance between the estimated position and actual position, and this way we will be able to find out the more accurate solution after applying the SOA algorithm and CSOA algorithm. Finally, we will be doing the some performance analysis and evaluation. So this is our task that we'll be doing now. So this high level diagram, it is now very clear, and now we can start from the very beginning. So so this is the abstract. I'll share this file, PDF file to ma'am now, and it can be shared to the all participants, those who needed, and further extend this work. So very first we will discuss what is node localization. So node localization, it is a process of finding the position of unknown node with the help of known node. That is diagram it is mentioning here now. So this process, we say it is called node localization. And in this node localization, there are so many approaches are there to find out the location of unknown node. So this is a very brief taxonomy of the node localization. So this is a broad classification, and then we'll come to the our exact point of this problem and solution. So if you broadly classify the node localization, there is a two categories. One is the centralized approach, centralized localization approach. You can say source target node localization approach. Another is the distributed node localization approach or self node localization approach. In the centralized approach, in the yes, ma'am. Is there any query? Yes, is there any query, ma'am? Somebody there asking something now. I couldn't hear. Shall I continue?
Yes, sir.
Okay,
Participants
fine.
are requested to mute yourself.
Okay,
Or in
ma'am.
case any
So
query, you can ask the question, but otherwise, please kindly mute. Yes, sir. You
yeah,
can
okay,
continue.
ma'am. Fine. Yeah, fine. So node localization can be broadly classified to two categories. One is the centralized localization scheme, and there is the distributed localization scheme. In the centralized scheme, there is a one central node, and there may be one or more than one target node. Using that, we are able to find the position of the unknown node target node, that is called single target node localization scheme. In the multi-target node localization scheme, there is a central node, but there are surrounding so many unknown unknown node that is not GPS enabled, and we are finding the position of all unknown sensor node with the help of anchor node, that is called multi-target target localization scheme. Yes. Further, there is another category of the centralized scheme, centralized node localization. This is called wireless binary sensor node localization. Binary means in the localization process, we are applying the some criteria. So there are the only two kinds of nodes are there. Then on the basis of this, we are just deciding that this node will be selected or rejected. That is called binary wireless binary sensor network, and in which we can find out the node using the centralized scheme. Again, here is a one anchor node, and there is a other type of node. So they will be selected or rejected because it is a binary sensor network. They will select if criteria is fulfilled, if it is rejected if criteria is not fulfilled. Similarly, there's a multi-target node localization using wireless binary sensor network. So there is a single central and single node, and here is a multi-target node and one central anchor node, and we are trying to find out the position of all nodes situated around the anchor node. So this is the centralized approach. But centralized approach, sometimes it is not very efficient and very efficient. Reason behind, we know that all sensor node are equipped with very limited battery and very limited resources, memory, everything. So if there is a one centralized node and so many target node, they are surrounded around that anchor node. So after some time, the power of the battery is not just sufficient for the targeting or finding the position of other node. So this method sometimes it is not very feasible, and it is found through the literature survey and research that key distribution scheme is more popular, and more number of research is now carried out and found on the research communities. So that is called distributed approach, in which one this is not any central anchor node are situated in this one. Here is some set of anchor node and some set of normal node, or you can say target node, that is deployed in the environment field. And now with the help of these algorithms, we are able to find out the position of the target node. Further, the distributed node localization technique can be classified into two categories. One is range-based node localization, another is range-free node localization. Range-based localization, where we are finding the we are either finding the distance between the anchor or target node, or through the angle of the just radio wave, how it is just going from one position to another position from anchor node to target node. That is called angle of arrival method. So there is three angle of arrival method now. Just yes, angle of arrival method, time difference of arrival method, and time of arrival method. So here we are using the time and the speed of light. If it is a radio frequency wave, then we are calculating the distance between the anchor node and target node. They are the range based scheme or method where we are calculating the range between the anchor node and target node. RSSI method, it is a receive signal indicator method. RSSI method is now cost effective and more popular. Reason behind, if we are going to apply the angle of arrival or time difference of arrival or time of arrival algorithm, here is the requirement of some hardware also. We cannot do the simulation on my computer without some set of hardware. Once we are connecting some sensor through my computer, then we can go for the computation of the channel. But RSSI method, it is obvious and it is possible to do the simulation and the analysis and some research outcome without involvement of any hardware if you are doing this research in the area of node localization. So that's why RSSI method is more popular and it is cost effective. And although the RSSI method is face the problem of attenuation, means if radio signal going from source to destination from anchor node to target node, what happen? There may be some obstacle in between now. There may be some weather condition poor. There may be some other surrounding condition, and these all things we know that affect the radio signal. So we will get the weak signal because of attenuation. So still RSSI method is now just face the problem, but because of it is cost effective, no hardware dependency is there, so it is more and more research we found in the area of RSSI. And there is a range free localization where distance is not measured. There is a some just DV hope count method where the subset of hopes are there, and it is counting the position of another target node from the anchor node by counting the number of hopes available in between the area now. And there is a multi-hope approach, means sometimes it is a single hope, means they are counting the only single hope, and if it is in the range now, it is calculating the position of target node. Multi-hope means it is if suppose our target node it is far away and in between there are more than one hop or node it is available, through that it is going to find out the location of that node. That is called multi-hope approach for the range free localization. Means range free, why we say? Because here range we are not computing, here we counting the number of hopes and then we are calculating the position of the target node. Gradient based approach is another approach, and point in triangle, this is the another approach, and centroid approach. In the approach, they are all free from the distance measurement, and we are able to find out the position of unknown node in the node with the help of these localization mechanism. So briefly I'm discussing about these all now. Then I'll come to the how RSSI method is now can be used for the computation of the position of unknown node, and then how can we apply the fitness function so that we can calculate the more and more accurate what is location, and we can find out the other parameter, how much computation time it is taking and what are the errors it is now producing after applying the optimization algorithm. So this is now that I discussed now. These are the existing method that is now very popular, and different researchers using the different method, and they are just now just putting the merit and demerit of each and every algorithm. So these are the algorithm, and I told that what are the existing and how RSSI method is better now. Reason behind it is a hardware independent and it is easy for the simulation and all for the better analysis of the results. Now come to the optimization technique that already we discussed in very detail. So here we will discuss about the nature-inspired meta-heuristic optimization algorithm in application, and that is the SOA algorithm, means sequel optimization algorithm along with the chaotic function. So there are some studies that I have done before doing these all works. So I'm going to skip this now research related work now. So because I discussed briefly what are the various method it is used by the research community to find out the location of the anchor node. So related work again, it is written over there, and so you can go through these all point later. So after this now, there is a one more thing. This is the algorithm SOA algorithm flowchart. SOA, not algorithm, SOA flowchart along with the chaotic. So before going to discuss this chaotic and SOA and NL all together, I'll come to the point what is the chaotic map. Then I'll get back to you on this point. So let's discuss about the what is chaotic map or chaotic function. So chaotic map means there is a one approach. We can deploy the sensor node in the environment field randomly. This is the one approach. Randomization of randomly, we are putting the two kind of node in our sensor field. One is that is here, you can see now in this diagram. Here we deployed the anchor node and target node randomly. This is the one approach. Second approach, chaotic map. It is a chaotic map. If you are going to use instead of random number, random number for the deployment of the anchor and target node, then it is found that chaotic map, it is better than the simple random number generation, and using that random number, we are deploying the sensor node and anchor node in the sensor field. So what is the characteristic of chaotic map and how it is better than randomization, simple randomization process? First thing, the chaotic map, it is a deterministic, non-linear, semi-stochastic, and sensitive dependency. Sensitive dependency means it is very important in the chaotic map how we are starting the what is the initial point we are taking to start this algorithm. That's very important. So we have to take care if you are going to embed our chaotic map along with the any meta-heuristic algorithm. So initial parameter, what will be the initial value of the parameter, or initial constant? So some calibration or some justification is needed before going to start why I'm taking this particular constant, why I'm going to take this initial value. Yeah, this is the only limitation that is written now, sensitive to dependency, and otherwise this is better than randomization process that we used to do using the random algorithm. So chaotic map, that's why we use for the purpose of just randomly deployment of the search agent that will be here now the seagull, and seagull will be now associated with this anchor node, and there is a target node. So all deployment, instead of using the random number, we will take the chaotic function, and with the help of chaotic function that you can see from this diagram, we are embedded the chaotic function with this seagull optimization algorithm. And in the seagull optimization algorithm, seagull is a bird that will act as a search agent for finding the location of the target node. And here this logistic map I have chosen, although there are so many chaotic map, you can find more than now just 50 or hundreds chaotic function I have seen on the Wikipedia. I just calibrated 10 chaotic map, and then after I found that this logistic map is more suitable for the simulation of this particular problem. So logistic map, this is a chaotic map. Chaotic map provide the better randomization, and seagull optimization just improve the error with the help of this fitness function, and and this way we will get the better results. So I hope you can understand why I'm going to use the chaotic map, chaotic function along with the seagull optimization algorithm. Now come to the scenario here. What are the simulation parameter I took now? I took the total 6 cases. In total 6 cases, there are anchor node, how much it is? Initially it was 15, but it is incremented by this now again 15. So it become 30, then 45, and this way it is now 90. So total 6 cases I took for the simulation of this scenario, and then we find out how much it is now error increasing or decreasing in this localization process. Similarly, the target node, it is now initially when it was 15, then target node it was 25, and when the anchor node it was 30, then it was 50, and when anchor node it is 45, then it was 75. So this is the approach that was taken, and transmission range in our simulation, it is now the 30 meter for our sensor node that is deployed for the localization of the other node, and sensor field area, it is 200 into 200 meter square where the sensor nodes are deployed. So very first scenario, it is here. Now you can see now here the sensor node and anchor node both are deployed randomly using the chaotic map function, and here initially 15 anchor node and 25 target nodes are deployed using the help of chaotic map. Second scenario, here 30 anchor nodes are there and 50 target nodes are there, and these 50 target node need to be localized with the help of the 30 anchor node. Similarly, the third scenario, here the anchor node are 45 and the target node are for 75. Similarly, here it is 60 and 100, and the last scenario here is the 75 and 90, and similarly 125 and 150 nodes are there for the localization process. So these 6 cases, sensor nodes are deployed. Then after, we find the distance between the anchor node and target node using the RSSI method, and then we applied the trilateration method to find out the position of the anchor node. By the way, the trilateration method, it is not discussed in detail, this one. So we are discussing here the RSSI method and what is trilateration method. If time will allow, then I will show separately how the trilateration method and how RSSI method work to find out the distance between these two are now. So coming to the results after the 6 cases simulation and result analysis. By the way, this is the data, that is the average data, not the complete data I put into the slide. It was not possible because the data, it was huge now. So I just put the average data instead of the complete individual data. So you can say there are the target node, how much it is now, 25, and anchor node 15, and then 50 and 30. See the 6 scenario. In this 6 scenario, each scenario we are just now trying 10 times. 10 means each scenario we are just running 10 times, and then we are getting definitely 10 results. Every time that I told at the very beginning, result will not be the same. It will vary every time, because meta-heuristic algorithm never give the exact results. They give the approximate results. That's why we do a lot of iteration, and then we take the average, and that average is sometimes better than any individual solution if they are some set of feasible solution. So that's why I took the average now. So 10 times this algorithm, these 6 cases are run now. So this first case, it is run 10 times. Then second case, it run 10 times. Similarly, all 6 cases we are executing 10 times. And then after, these are the results that we got now. The very first, it is there is a SOVA algorithm. We calculated all 6 cases using the SOVA algorithm, that is called Siegel optimization algorithm. And we are calculating the 3 parameters. First parameter, ANLE. This is average node localization, E for error. Means how much error it is coming if we are applying the SOVA algorithm to find out the distance between anchor node and target node. So these are in the meters. Means the scenario is when anchor nodes are 25, anchor nodes are 15 and targets node are 25, then how many average node it is localized? Out of 25 node, only 15.6 we can say, because it is average, that's why it is going the fraction value. So you can say 15 to 16 node it is able to find out if you are applying the SOVA algorithm, and we are having the what is 15 anchor node and 25 target node. So average node localization 15, and time in millis, it is second. It is now 0.462 second. It is taken by the average time. It is now average time for node localization. It is now 0.46, and the error is equal to 1.3145 meters. This is called the localization error. Means this if number of anchor node is 15 and target nodes are 25, only 15, 16 node are able to find out, and their average error is how much? 1.3 meters is the error. Means this algorithm is not finding the exact position. This much is error, but it is able to find out the position of the sensor node, although the sensor node not deployed with the GPS module. Similarly, you can see as the number of anchor node and target node we are increasing, then you can see the trend of results. What is how much? When it was 15, it is found only 15, 16 node. But when anchor node and target node density it is increased, so it is able to find out how much? 42 node. And similarly, when it was 75, it is able to find out approximately 64, average 64 node or 63.8 node. When it was 100, it is 91, and then 115 in case of 125 and 141. So this is a result that we are seeing now. So if I am going to show the average node localization in case of SOA and CSOA now, so this is called average node localization. It is just showing how much it is now. It is this in case of CSOA, it is every time better than the SOA algorithm and SOA algorithm. And this you can say as the number of anchor node and target node density we are increasing, the accuracy is now better. Means number of node localized out 100%, it is showing in percentage now. So percentage of node localized, it is much better as compared to the first case. If you are going to 6 case, so first to 6 case there is a huge difference, and we are able to find out the number of target node modes. So you can say accuracy is improved because of the density of the node density if we are increasing. Along with that, we can say the SOA algorithm, it is able to find out the results, good result. But if you are going to apply the chaotic MEMS because of better randomization, it is now giving again the better result as compared to the SOA algorithm. Now, similarly, the second, this is the total node localized, and this is the error, and this is the time. So if I'm coming to the error, you can see here error is in case of first case, that is 15 anchor node, 25 target node, it is 1.122, and here it is how much? In case of SOA, it is 1.315. So you can say this one is meter, it is more than this one. Similarly, here it is 0.946, and here it is again the huge difference, it is 1.26. So in all cases, we found that CSO algorithm is able to give the better results because the localization error that is in meter, it is less than normal SO algorithm without using the chaotic map hybridization. So we can see the result here. This is the what is a error drop. Now what happening here now, if it is the density it is increasing, then what is happening now? We are calculating here error between anchor node and target node. So this, if we are going to increase the density of anchor node and target node, then obviously it is going to decrease the error. And in the last case, when anchor node are 60 and target node 150, there is a huge difference between the first case and sixth case. Now the error is less, and when in the first case it is approximately 1.1 and 1.3 using SOA and CSO algorithm, but in the sixth case when anchor node are 60 and 150, it is reduced a lot, and the error in between now something 0.7, and in case of CSOA, and it is 0.8 meter in case of SOA algorithm not using the chaotic map. Last data here is now the computation time. Again, we can say the computation time, obviously it is increasing. You can say the computation time, it is increasing here and here, but computation time again, it is less in case of CSOA algorithm, and computation time in case of SOA, it is now more. And you might, it is but obvious, if the anchor node and target nodes are more, then definitely computation time will increase That's why the time it is although increasing in the computation of the target node, but if you are applying the CSO algorithm, it is able to find out the result in lesser time as compared to the SO algorithm. So this is the about the simple meta heuristic SO algorithm for optimization purpose, and it found that it is giving the better solution if you are applying the chaotic map along with the SOA. And one thing that is not here mentioned or compared, if I'm not going to apply SOA even algorithm, we are going to apply only RSSI method and some localization technique, that is trilateration or multi-trilateration method only, and we will be able to find the location of the target node. But again, it will give the more error and more error. One thing that will be definitely reduced, that is computation time, but doesn't make any good sense. If our time we are saving, but our result have a lot of error, then I think our objective is not fulfilled. That's why in the today's scenario, somehow optimization algorithm, they are important, they are very popular, and definitely if we go to survey and see the just research community, a lot of work is going to implement with the help of meta heuristic optimization algorithm. But I would like to remind again, where meta heuristic algorithm is suitable, where we are not looking for the exact point of solution. This kind of algorithm can be applied only when we are looking for approximate solution, and we want to save our just computation time, our cost of computation, or time of computation, then only it is efficient algorithm. Suppose you are going to do the surgery of any person, and their sensor body area network is there. Now some sensor are deployed, so definitely the optimization algorithm, their meta heuristic algorithm cannot be applied at that point of time. Some deterministic algorithm, some artificial intelligence kind of thing we have to embed it to find out the exact solution, because otherwise what will happen, we are going to operate the brain and we may operate the chest. It may be possible in this scenario if you are going to apply this. So these are the merits and demerits of using the meta heuristic optimization algorithm. There is a future work. If looking for this particular work, I used only the chaotic map. There is another similar kind of and very good characteristic, that is called Levy flight. Levy flight, this somehow it is more random as compared to chaotic. So theoretically, if it is more random and more good characteristic for the randomization it has, then definitely chances are more if Levy flight, if you are going to apply in the any optimization algorithm for the searching purpose, then it's, in my view, it may be the better than chaotic optimization algorithm. So this is all from my side, and please ask question if you have any doubt regarding this my all discussion that we just had it now. Ma'am?
Yes, sir. Any questions from the participant side? I think the topic and the content is already clear to the participants.
Okay, ma'am. So I'm done. So shall I stop now?
I, yes, sir. Thank you, sir, for your enlightening session. We are grateful to you for your
Okay,
time
ma'am.
and effort in sharing your knowledge with us today.
Thank you, ma'am. Thanks a lot. It's
Sir,
okay.
just wait for 2 minutes.
Yeah.
I
Okay.
request all the participants to switch on the camera for the photograph.
Hmm.
I request all the participants to switch on the camera for the group photograph. Okay, thank you everyone. Thank you, sir, for your time and effort for the session. Thank you, all the participants. We will meet at 2 p.m. for the next session.
Thank you, ma'am.